Hello everyone! The objective of this video is to discuss the following. Pag-uusapan natin ang screen analysis, ano ba ang significance ng screen analysis, and what are the ways or methods to report the screen analysis, or in some other references, we call that the sieve analysis. And after that, we will be visualizing the size fractions of the compiled data. After ulit niyan, meron pa tayong isang topic na pag-uusapan which is the screen effectiveness. So, i-discuss natin kung saan nakukuha ang formula ng screen effectiveness, ano ang recovery, rejection, and mass fractions, and to conclude our topics, I'll be giving or discussing some sample problems in order to apply the knowledge that you have obtained from the following topics. Now, we begin with the screen analysis. Sabi nga nila, ang screen analysis daw ay isa sa mga pinakamagandang paraan para i-evaluate ang screening operation. So, dito natin makikita kung gaano ka-efficient ang screening process, kung gaano ka-effective ang ating mga screen. So the testing of screening operations are making use of what we call the testing sieves. So i-discuss natin mamaya kung ano ba or paano ba gumagana ang mga testing sieves na ito. Also, in screen analysis, ang goal kasi natin dito ay makuha ang percentage ng mga materials na nagpa-pass through doon sa screen or tinatawag natin ito na undersize, or kunin ang mga materials na nagre-retain doon sa ibabaw ng mga screen or tinatawag natin sila na oversize for that particular screen. So, ang gist ng screening analysis is maglalagay tayo ng specific amount of material dito sa ibabaw ng ating series of testing sieves, and then after some time ng ating pag-shake dito sa system na to, makukuha natin yung amount ng materials na may iwan sa bawat screen. So mamaya I'll be discussing that even more in details para mas maintindihan natin itong screening analysis. Now, what is the purpose of screen analysis, or ano ba ang significance ng screen analysis? One is that we will be able to identify the effectiveness of a specific screen size. So, di ba nga kapag nagde-design tayo or if we are building a series of screening mechanism, kailangan alam natin kung gaano ka-effective at ka-efficient yung binibuild natin. So it is stated here that screen analysis is also used in order to select the appropriate screen size for a specific material feed. Kaya sinabi natin dito na specific material feed kasi hindi naman lahat ng feed natin ay pare-parehas ang screen na ginagamit. Let's say if we are going to screen some aggregates, some grains, or other chemicals, ibig sabihin meron silang kanya-kanya na screening specifications na kailangang gamitin. Now, for the overview of the steps for screen analysis, we have 5 major steps. One is the sample or yung sampling. Siyempre, kailangan natin kumuha ng sample from that specific material that we want to screen, and usually nakadepende ang sample na yan sa nature ng planta. If you want to, let's say, screen some coffee or pharmaceutical materials, or yung sinabi natin kanina, aggregates, grains, kukunin natin iyan syempre doon sa storage. Some storage systems are in big containers or silos, or kumbaga yung iba, they just use huge piles of it or of the material, and then kumukuha sila doon sa ibabaw, sa gitna, or ideally doon sa bottom, noong mismong huge pile of that material. And then after that, syempre, i-collect na natin yung sample na kinuha natin, and that should be secured. Syempre, ayaw naman nating makontaminate yung sample natin. You should be able to secure it from foreign objects to be mixing with that one. So, dapat specific tayo doon sa containers natin. Also, we should consider the other thermodynamic properties that may affect our material. So, say for example, meron tayong material na kailangan ng maintaining pressure or maintaining temperature. Therefore, you also have to adapt that in your containers na paglalagyan before transporting it. And also in transportation, if your material depends on some time, 'di ba? Hindi naman kasi lahat ng materials parang pwede silang i-travel ng ganoon katagal. Ibig sabihin, ang variable dito is the testing center. If your material should not be transported for a very long time, kunwari hindi niya kayang magstay ng 1 day sa labas, it's either you adjust your transportation, pwede kang mag-set up ng facility that will contain your material very well. Kumbaga walang magbabago doon sa properties nito, or you should be able to have a very near, or you should find a testing facility that is very near to your storage facility. Okay, kaya ideally kapag meron kang storage facility, yung testing facility mo ay malapit na rin doon sa storage. Next is to prepare. Doon na sa testing facility, you should be able to prepare the necessary equipment, the apparatus, and of course, the data gathering material that you are going to use for the testing. Also, there are precautionary measures that you should observe before testing your material. And in our testing part, it is when we will be gathering the data that we need, and of course, to evaluate and analyze kung ano ba ang sinasabi ng mga data natin na yan. In the testing part, nasabi ko nga kanina, meron tayong tinatawag na testing sieves. Generally, testing sieves are used for control and analytical purposes. For example, gusto nating i-identify or i-determine ang efficiency ng isang screening device, then testing sieves are very good in identifying that. Or if we want to identify how much work was done by our crushing equipment or grinding equipment, then testing sieves are also used for that. Ang testing sieves natin ay usually, they are constructed using woven wire cloths. So, depende yan doon sa specified standard. So, yung mga wire cloths na yan, as you can see, ito, depende kasi yan sa material eh. Kung mapapansin ninyo, meron tayong frame dito, and that is with a specific diameter. So, madalas, ang mga testing sieves ay may diameter na 8 inches. And yung height naman, or kumbaga itong thickness dito, yan ay, lagyan na lang natin dito height, that is around 2 inches. And kung nakita ninyo kanina yung stacking height natin dito, ang testing sieves natin ay naka-design in such a way that if you are going to place one pan on top of the other, it will be secured here. And then at the bottom, syempre meron tayong collecting pan. It would be important, or it would be very essential that our standard testing sieves have their standard size as well. So meron tayong tinatawag na Tyler screen standard, wherein we make use of screen intervals na square root of 2. Let me just insert this mesh system. Pag sa screening kasi, 'di ba, meron tayong series of screens. And speaking of that, meron tayong designation, meron tayong notation para sa mga undersize and oversize na yan. If a material has passed through, let's say meron tayong 20 mesh sieve sa taas, tapos 24 mesh sieve sa ibaba. So, na-identify ko na sa taas yung 20 mesh sieve kasi mas maliit yung number na ito. Remember, if you have a series of screens, let's say this is the first, second, and then the third one. Lahat ng screens na nasa upper part, sila yung mas maliliit yung mesh number. Ano ba ulit ang mesh number? That is the number of openings, or the ratio of the number of openings, or yung screen apertures natin for every inch. Or kumbaga, pag sinabi natin na 20, ito, pag 20 ang mesh number ng screen na yan, ibig sabihin, meron tayong 20 na butas sa screen sa bawat isang inch na length nito. Okay? And then the next screen here will be, let's say, 24, and then dito, 30. Okay, approximation lang yan. And then, ang tinutukoy dito sa ating mesh system or our designation is that if you have 20 all over 24 or let's say negative 20 and positive 24, ang gustong sabihin yan ay yung nangyayari dito sa pagitan na to. Okay, pag sinabi natin na negative 20, negative stands for the undersize or all of those materials that has passed through the mesh number or yung screen na may mesh number na 20. So, lahat ng materials na finid mo dito sa taas, tapos nag-pass through dito, they are considered undersize. Undersize, again, ng 20. So, nakalagay dito, negative 20. And then, tuloy-tuloy naman yan, magpa-pass through pa rin yung ibang materials dyan. However, there are materials that will be retained on top of that, or this 24. Ibig sabihin, kapag na-retain ang mga material na yan sa ibabaw nito, sila ay oversize ni 24. Ibig sabihin, kapag oversize sila ay may designation na positive and ilalagay mo dito yung mesh number. That is why for this example, meron tayong negative 20, positive 24, or in some other references, they call that the 20/24 or 20 all over 24. Basta yun lang yung ibig sabihin. Undersize doon sa first na screen and then oversize naman doon sa susunod na screen or kung saan sila naiwan. Kapag i-identify naman natin yung materials doon sa susunod na screening natin, let's say, di ba kasi nagtuloy-tuloy naman yung screening dito. Ibig sabihin, meron pa rin namang tatagos sa part na ito and they are already considered not the oversize but they are the negative or the undersize of 24. That is why if you are going to designate its size, it will be negative 24 tapos lahat naman ng may iwan dito will be considered as positive 30. Okay, eto. Kung titingnan nyo itong mga to, lahat ng materials na yan, pag naiwan yan sa ibabaw dito, they are the negative 24 and positive 30. And so on. Ganun lang yun. They are the standard designations of our mesh system. So, going back to the standards when it comes to our screen. So, sabi natin kanina, ang testing sieves ay dapat may standards para mas maayos yung screening analysis natin. So, sabi natin last time, ang screen interval ay yung relationship ng successive sizes of the screen openings in a series of screens. So, kumbaga, meron tayong series of screens up until the last screen. So, kumbaga, nag-designate tayo ng screens na may apertures or screen openings na pinakataas, 10 inches, 9, 8, 7, 6, 5, up until dun sa last natin na screen which has a 1 inch screen aperture. So, as you can see, pwede naman. This one is possible, however, it is not commonly used because there is a large relative difference between the 1 inch and 2 inch sizes. Kumbaga, kapag nag-screen ka ng mga materials doon sa may openings na 2 inches and then 1 inch, sobrang laki ng difference. But if you're gonna take a look at the 9 inch and 10 inch screen openings, they are almost alike. But this one is just used for practical uses. Okay, so ang point kasi nito, parang hindi maganda yung ganitong series kasi meron tayong nami-miss out na sizes. What if, sabi nga dito, doon sa may 1 inch to the 2 inch sizes, meron tayong mas maliliit pang sizes na nami-miss out between them and that is not practical. Kasi, what if yung size pala na yun ay ang may pinakamaraming quantity doon sa mismong feed mo. So, sayang, di ba? Hindi mo na screen out. Ibig sabihin, nakamix pa rin ito doon sa may 1 inch. So, ano ang naging solution nila dito? If you have a series of screens, gumamit sila ng multiplier or let's say an interval of 2. So, let's say, kung meron kang 1 inch na opening, yung nasa ibaba mo na screen ay may openings na 2 inches. And then, since ang interval nga natin or ang ating multiplier ay 2, the upper screen to that will have an opening of 4 inches and then 8 inches dun na sa pinakataas. And kung pababa naman, syempre, i-divide mo lang yung this size, the 1 inch to 2, so that will become 1/2, and then 1/2 divided by 2 will become 1/4, and so on. And as you can see, these sizes vary in geometric progression, and sabi nga natin kanina, ang factor or ang screen interval ay 2. But if they still want a closer sizing, they just have to insert an additional screen between the original screens. Kumbaga dito, sa portion na to, maglalagay lang sila ng isa pang screens dyan. So, ibig sabihin, ang mangyayari na sa screen interval natin ay square root of 2. Now, for careful work and some other researches, meron pa rin tayong ginagamit na special screen interval wherein our multiplier will become the fourth root of 2. Okay, so usually sa sa mga research facilities, and yun talagang very specific or very critical in their sizings. Now we have here an example of a Tyler screen standard. So sa table na to, papakita natin yung different apertures or openings ng screens with their corresponding mesh number and wire diameter in inches. So this table is actually based on this one. So this is a 200 mesh screen that already shows its screen interval, sabi nga natin kanina, square root of 2, and its corresponding wire diameter is 0.0021 inches. Ngayon, ang opening ng screen na to ay merong size na 0.0029 inches. According to our mesh number, kapag sinabi natin na 200 mesh screen, ibig sabihin yung screen ay may butas na 200 or 200 openings sa bawat isang inch. Ngayon, paano ba ginagamit ang Tyler screen standard? Say for example, mag-i-start tayo dito sa 200 mesh screen and we want to place a screen on top of it. So according to our multiplier or screen interval na square root of 2, all you have to do is to multiply this one by square root of 2. So 0.0029 times the square root of 2, makakakuha tayo ng value na 0.0041. Kung maglalagay naman tayo ng screen sa ibaba nito or gusto nating maglagay ng screen na mas pino yung butas nito, all you have to do is to divide this one by square root of 2. So 0.0029 divided by square root of 2, makakakuha naman tayo ng 0.0021. But if we desire to use a closer sizing, sabi nga natin for careful work or some research purposes, pwede rin tayong gumamit ng interval na fourth root of 2. So, ganun pa rin. From 0.0029, for example, all you have to do is to multiply it by the fourth root of 2 and then makakakuha tayo ng 0.0035 instead of going directly to 0.0041. Kapag mas pino naman na screen, all you have to do is to divide that one by fourth root of 2 at makakakuha tayo ng from 0.0029, pupunta ito ng 0.0024. Dito naman na yung mesh number at yung wire diameter. So, ganun din sa iba pang sizes, and that is for the use of a Tyler screen standard. Now, let's talk about the method of making screen analysis. Meron tayong 5 steps na dapat tandaan kapag nag-a-analyze tayo ng screens. 1, you must remember the individual screens. Ibig sabihin, kukunin natin yung individual test sieves na merong specified scales. So, for example, meron kang 3 mesh na screen, 200 mesh na screen, depende yan sa gusto mong i-test na screens. Okay? And of course, lagi nating nililista yung mga data na ito. You must complete the set. So, kapag kumpleto mo na yung set, dapat meron kang pan that will catch all of the undersize, and dapat meron din tayong cover dito sa taas. So, syempre, ang purpose ng cover is to prevent the materials from going outside during the screening process. Of course, you have to remember that when you are going to stack your screens, the larger mesh should be on the top part, at syempre yung pinaka-pino na mesh or yung pinakamalaki na mesh number ay nasa pinaka-baba. Of course, our purpose is to have a screening process that will get the finest material dito sa pinakababa. Third one is to place the material. If we have already weighed the sample na kinuha natin kanina, let's say our sample is 1 kilogram. Lahat ng 1 kilogram na yan ng material ay ilalagay natin dito sa itaas. Siyempre may cover dyan, tanggalin mo muna yung cover and then you place the material and put the cover back to its position. Kapag inilagay mo yung 1 kilogram dyan, some materials will be passing through, some are not. Pero hindi nagtatapos doon ng screening process kasi syempre, marami pa tayong hindi na-screen. That is why we are going to apply a shaking mechanism or the one that will apply force to the whole system. Dati, gumagamit sila ng hand method or that is manual na pag-shake. Kumbaga, takpan mo to, tapos i-secure mo lahat ng sieves into their place, tapos i-shake mo yan manually. As you can see, that is open to error kasi pwedeng hindi uniform yung pag-shake mo dito, ibig sabihin hindi uniform yung amount of force applied. Also, hindi distributed yung amount of force. What if nakakapit ka dito tapos dito lang yung nasi-shake mo? So that is quite erroneous. Okay, that is why we result into automatic operations or those that make use of machines. So, isang popular machine na ginagamit in our sieving or screening mechanism is the Rotap sieve. So, let me just advance it here. Ang itsura ng Rotap sieve ay ganito. And as you can see, yung stack ng ating screen or testing sieves are already placed in this one. So, syempre, isi-set na dyan yung time and then nakaset din naman dyan yung force ng pag-shake dito. And then after some time, pwede na tayong mag-analyze ng screens. How? Kunin natin yung mass ng oversized materials na naiwan sa bawat screen. So, kunwari, may mga naiwan dito na ganitong amount, dito sa second, third, up until the last one, kukunin natin lahat ng mass na yan. And from that, sabi nga natin kanina, di ba, meron tayong 1 kilogram na amount of feed. So, ibig sabihin, let's say this portion. So, kunwari meron tayong 200 grams ng material na na-retain dito sa portion na to. And our total amount of material fed into this one is 1 kilogram or that's 1,000 kilograms. Ibig sabihin, ang fraction na to or ang percentage na to with respect to the total will be 20%. Or that is 0.2 of the whole material. Okay, so ganun lang naman. Yun kasi yung goal eh. Ilang percent ito ng total. And even this one, how much of our total materials will be retained in this one. So ganun lang. I-measure natin yung mga mass. And that is, of course, with respect to the whole sample. Meron tayong mga factors na nag-a-affect doon sa results na makukuha natin doon sa screen analysis. One, pwedeng mag-overload yung mga screen natin. There could be some blinding or adhesion doon sa ating mismong apertures. That is why hindi maganda yung results natin. Also, pwede tayong magkaroon electrostatic forces. So, yung mga small particles ng ating material ay kumakapit sa isa't isa. And that is not very good, especially when we are screening materials. And lastly, did you know that small amount of moisture could also affect our screening process or our results because they tend to, ayun nga, sabi natin kanina, adhere to one another or even to the apertures. Yun. So, what can be done when it comes to these problems? Pwede tayong wet and dry screening. Let's move on to the method of reporting the screen analysis. So, syempre, kapag nag-gather na natin yung data, specifically the fractions ng mga materials na na-retain doon sa bawat screen, dapat meron din tayong paraan para, let's say, i-tabulate or i-graph etong mga data na to. Our ways in reporting the screen analysis are as follows. We could calculate the mass percentage of each fraction. Or we could also calculate the cumulative percentage of size fraction retained on each sieve. Kumbaga, ito yung mga oversize natin. And the last method in order to report the data from our screen analysis is by calculating the cumulative percentage of size fractions through each screen, or kumbaga yung mga undersize naman yan. Now, there are two ways to visualize the size fractions of the compiled data. One, pwede tayong gumamit ng fractional or differential plots, or we could make use of the cumulative plots. First one is the use of fractional or differential plots. So, itong mga plots na to ay gumagamit lang ng one mass fraction doon sa ating screens. Yun yung na-measure natin kanina. And second one is to know the average sieve size. Pag sinabi natin na sieve size, ito yung apertures. The advantage of using differential plots is it is focused on our material feed. Yun nga lang, kailangan pa nating mag-compute ng average sieve size.